to piece together, with the end result here being the display of your actual website. So request goes up from the browser, returns the source code and the code for the website, which then sends out to the server that the website's sitting on, which is returning everything that is being requested there. Your browser, so like your Chrome, Firefox, whatever it is that you're using, is then compiling all of that and then rendering it, putting it together, and displaying what it is on your website, which is pretty simple, right? Not quite. So within the source code of your website are also the things that we are referring to as tags. So what tags are is the little snippets of JavaScript that are also powering different functionality on your website. It might be, in this case, what's highlighted here is Google Tag Manager, which is a container code which contains or houses a number of other tags. So that might be there. Your analytics platform, whatever script is there for that, or that tag might be within your source code. A/B testing, the whole gamut. So all the marketing, advertising technology on your website is going to have a tag that's going to live within the source code or within something that is in the source code. So as the browser goes through and reads these different areas, it is also going to be sending up requests for information and for content or for images or just setting up information data points to the respective servers for all of those different platforms. So on one website, say you're using Google Analytics, you're tracking conversions within Facebook, tracking conversions within Twitter, tracking conversions for DoubleClick, and also using something like a Criteo for remarketing. As all of those different tags are read by the browser within the source code, there's going to be requests going up to those various different servers, which are going to be returning information or returning additional content, might even be returning another tag that is then being injected into the page. So it's a pretty complex environment, a lot of requests going out, a lot of work being done both by the user's machine as well as by the user's browser. And then also on the actual platform server side, they're having to collect and capture those requests and run the processing on that point to return whatever it is that's being asked for. So that, at a high level, in 3 minutes, is how your websites work. How it is that they're going out, a user comes and is able to see all the content on your website. You're also able to run a lot of these different processes and things in the background, display dynamic content, things like that. So here's just a quick screenshot just to help you visualize the request piece a little bit more. So within your browser, you can always see all the different requests listed out within the developers tools. This is with Chrome, but looking at the network tab, and that's going to show all the network requests. So everything that's being sent out by the browser, it might be sending it back to the site domain or the site server in order to pull in images, again, videos, content itself is going to be, you're going to be able to see those requests there, as well as any requests going up to third-party tags or third-party platforms that are running some other functions. So that, again, basically just how it's all working for both your sites and then as well as the tags on it. And as you could see with those different visualizations and that explanation, there is a lot going on. And all of those requests, all of the processing, all the data that's being returned, it all has an impact on performance. And what we'll cover here is exactly how. So to start, just to go through a few different performance basics. So a few of the key terms that we'll use today, and then I'm sure you'll hear thrown around as your development and your operations teams are talking about website performance. So the first thing, when you hear me or someone else refer to something as the client, They're not referring to the customer or anything like that. What they're referring to is the user's browser. So that is, if something is run client side, it's run on the user side, on the user browser, on the user's browser. The second piece, server, which you saw in those previous illustrations. The server is essentially a computer, a hard drive that is going to be sitting out somewhere else, which the client's browser is going to be communicating with. So that's where all your actual website files sit. That's where all the content sits, all the images, all those good things are sitting. Third thing here is processing time. So this is how long it takes information to be consumed and then an output sent. So think of this as like the time it takes to crunch the numbers. If a tag is trying to run a function or do something on the site, even if it's client side, for example, the processing time would be the time that it takes for the browser to run through that script and actually do whatever it is that it's asking to do. Fourth thing here is latency. Now, we hear latency tossed around quite a bit. The dictionary definition in the context of computing is the delay before a transfer of data begins following an instruction for its transfer. So, as we were talking about with the requests and everything before, this would be the time from the initial request being sent or leaving the page or leaving the browser until a response is first registered. So for tags, the moment that the JavaScript tag for that platform sends up the request to the time where it first begins hearing a response. You can think of this like if you ask someone a question, for example, the time that it takes for them to think about the answer and then begin to respond would be the latency. Next thing here is the requests. So those are most basic way of thinking about them is just the requests for information. So if or when a tag sends up a request that is asking the server or the computer that it is corresponding with or communicating with to return it something. So this could be the request to the actual site server, like I just mentioned, for the contents of the site. It could be the tag request for whatever information it or that platform is looking for, etc. But again, you can think of these as the questions that you would be asking in that previous context. The next thing is CPU, which stands for Central Processing Unit. This is like the engine of your machine or the engine of your computer. So this is a fixed amount based upon the device that you're on, but you only have a finite, because it is a fixed, you have a ceiling, you only have a finite amount of power to be able to do things on the machine. And it can only handle so much at one time. So that processing time, for example, is directly affected by the CPU. If you're trying to run a lot of different programs, and if you're like me and you have 50 tabs open in your browser, it's taking up a lot of CPU. Running all those different tools, different web pages, and loading all of that content and holding it there in the background takes a lot of that CPU. So that's the power that you have to process what everything on your website in that context is trying to do. Next thing there is bandwidth. So this is the amount of data that is capable of being sent and received at one time. So a common way that you'll hear a lot of people refer to this as, or it's commonly thought of as like the connection speed of the user. So in many ways you can think of it about how fast their internet is. But it factors in because it determines how much of a message can travel at one time. So I know it's a little bit of a leap to think about the amount of data capable of being sent and received and correlating that with speed. But if you think about it like communicating with someone via text message, right? And if you're only allowed to send one word at a time versus being able to send whole sentences at a time, you're going to be able to communicate with them much, much faster. In the second, where you're able to communicate or write out and send full sentences as opposed to individual words at a time. So more bandwidth that someone has, the faster and the more information can be sent back and forth with a server or with another machine. Next thing here is the request size. That's just purely the amount of data that's being sent and received. So every single request that's going out has a payload, right? It has data that it is carrying within that request. The size of that is going to be written out. You're going to see it within that network tab, for example, in bits, kilobits, megabits, and that is just the size and how much is being sent and received. A couple other terms that you'll hear are synchronous and then asynchronous. So what synchronous are synchronous requests are requests that must be sent, processed, and received without anything else happening. So, well, I guess first conversely, asynchronous are things that can happen, requests that can go up, send, execute, come back, all in parallel. So very, very important here, the distinction between these two different things and how tags are behaving. If it's a synchronous loading tag, it's the only thing that can be going on at that particular point. So it's going to block your actual page content and the page from loading. Whereas asynchronous, those are able to run in parallel with other requests, as well as the page contents, style, the whole nine, loading in parallel. So it's not going to actually block anything else from loading in a perfect world, I guess that is, and we'll get to that here in a moment. So these are the basic definitions or definitions for the performance basics and what it is exactly that we'll be talking about. All these things factor in together. All of them combine together to affect the performance of your website, the response time of your websites, and then also as an extension, direct extension would be how users are able to experience your website. So piecing it all together. So taking those performance basics and then at a high level, so we went through exactly how your website works. So every single thing that's happening on the site, be it the content, be it the images, be it the videos, be it the social sharing widget that shows up, the analytics, all of that's happening by requests going out to different areas, servers processing those requests, sending back whatever information it is that's being requested, and then your browser putting it all together. So the infrastructure looks like this. So you have the client, which is the browser. You have your connection or your pipe, which is literally the internet. And then you also have the server on the other end. So this is what the infrastructure and what everything looks like. I'm going to use this visualization here as we go through. So on the client end, what is it on the client side that really affects performance, right? First thing is the CPU. So how much can the machine handle in terms of processing time and effort? So again, like I had mentioned before, when we were going through the definition for CPU, it's like your engine. And if you think about it in the car context, or even if you're running, so your engine can handle only so much. The more strain you put on it, the more you try to get it to do. Some are going to be stronger than others. So with the CPU, that's going to depend upon your user's machine. So if they're using a very high-end computer, you're going to have more CPU. If they're using something like a Chromebook or a mobile device, going to be much more limited. So that, because of the processing effort and what is possible on the client side, based upon the CPU available for that machine, is going to affect performance. It's going to affect how quickly different things are able to be processed on that end, how quickly the browser is going to be able to capture all the data being sent to it and compile it together to be able to render the web page and display to the user. Second thing on the client side are browser limitations. So one, browsers use a lot of CPU. Different ones will use more or less, just based upon how they're written, what it is exactly that they're doing. But also, browsers have request volume limits, and this varies. It varies, one, based upon the browser type, based upon the browser version, but also there are limits of requests to the same domain. There are limits to total requests that can be sent and be outstanding at one particular time. So these browser limitations, when it comes to volume of requests, so if you have a website and say you have 100 tags that are loading on a particular page, each one might be sending multiple requests because it might be sending out a request, getting information, processing it, sending it out, processing it, coming back, and kind of pinging back and forth. It's possible to be able to hit that request limit on the browser, both to the same domain as well as in aggregate. And when that happens, the requests have to wait until others are finished processing before they can actually fully execute and fully be sent out. Another thing to keep in mind on the client basis, and we're not going to get into it too much, but just the site code in general. How complicated is it? How long is it? Your browser does, read in essence through that entire site code. So if a site, if the source code is 100 lines versus 100,000 lines, one, obviously the shorter is going to be able to be read much faster. This is a major factor when it comes to tags, because if you have a number of tags, even if they're, say piggybacking or loading through another tag or another pixel and injecting additional code into the DOM or into the page, that's going to lengthen that. It's going to be more work and more time for your browser. So those are the primary things that are factoring in to performance on the client side. Now, in the middle of that infrastructure is the actual connection or the pipe, so the internet. The biggest factor on the connection and the pipe as it relates to performance is the bandwidth. So you can think of bandwidth as the size of that pipe. So how much can the internet connection handle at once? Someone that's accessing the internet on, say, like LTE or with their like 4G network on a mobile device, the width, the size of their pipe, so the amount of data that can be sent and received at one time is going to be much, much smaller than someone on a full Wi-Fi, 20, 30, 40 megabits, or even gigabit now, internet connection. So that bandwidth or the size of the pipe is going to directly relate and directly have an effect on how much can be sent and received at one time. If your website is trying to send and receive more data from a size standpoint than what is available from a bandwidth standpoint, then requests are going to stop. They have to wait their turn. Now, your browser does a pretty good job of prioritizing certain things over others, but it is going to slow down the process. It's going to take longer for requests to be fully executed and every single request sent and fully executed due to less being able to happen at once. Another piece that is often forgotten with respect to the connection of the pipe, a lot of times we forget that distance traveled matters a little bit as well. We forget that the internet is literally a bunch of wires. And while it's a small difference, location does matter. A great way of thinking about this, there was I believe it was a 60 Minutes piece about a year or two ago in the financial services industry where people are trading stocks and certain people were able to lay high speed and a shorter distance wires to where they were trading. So they were able to algorithmically with their machines see when prices, and granted it would be, maybe the price of a stock went down a penny or up a penny, but they were able to make trades based upon those changes in fluctuation faster than anyone else. So you can make high volume trades of those small amounts because you're able to beat everyone else to the punch. You essentially could see into the future. And a big piece of that was due to the wires that they were sending that on, and also the distance that was being traveled. So with data centers and where things are being served from does matter. If your users are in Europe and the servers from which requests are going up to, and the messages and the data is being returned to are all in the US, that's going to take a little bit more time than if everything's being served from somewhere in Europe. Last piece here, connection speed, just how quickly can our requests and responses travel. That directly relates to what I was mentioning previously with the distance. So that's that connection, or that pipe in the middle. So where everything is traveling, that highway that everything's going back and forth on. How large is it? So how much can be happening in parallel at one time? How far do these messages and these requests have to travel? And then how quickly can they move back and forth? Third piece here is on the server side. Now, a lot of times people will talk about latency, and that was one of the things that I wanted to come back to. A lot of times people will confuse latency, start using it for how long it takes for something to finish executing or to fully load. Latency is more, like I mentioned in the definition, it is the time from a request being sent to the time that the response initially happens. So a big part of latency is going to be one on the server side. So those requests go out to the platform and for a tag to that particular platform's servers, and those could be local to wherever the company is operating. They could be cloud servers, but regardless, that request has to go up to those. It then needs to be processed, and then something needs to be returned back to the site, whatever it was that was being requested. That processing time is what's factoring into latency. So a lot of times you'll see SLAs around the latency of a particular platform. Another thing is going back to, even related to that, is what's happening between the request and the server, which again is going back to that connection or those pipes. So with the bandwidth, location, where things are being served from, that sort of thing. But a big piece of latency is on the platform side. How efficient and how well are their servers running? Another thing here is processing time. So once that request, again, reaches the particular tag or the vendor's servers, how quickly is that request being processed and then turned around with the response? And then, again, the location. Where are the servers? Are they local? Are they regional? If you have global users and global clients, your clients are located globally, you at least need to be regional with where everything's being served from. So that is the infrastructure. So you have the client, which is making the requests, the connection to the pipe, which is transferring, and that's the highway that those are moving on, and then server side that's actually collecting that request, processing the information, and sending back a response. So tags, I know I have tags kind of free-flowing through that connection pipe, ending up at the server, ending up at the client. The tags, as we're referring to them, are only sitting on the client side. It's just the scripts that are being executed. When we talk about seeing a tag, what tags are there? What platforms are loading from the site? But the requests that are being sent up from tags, like we had mentioned and gone through earlier, are also going through this entire process. So each tag is being executed. The requests are being sent out to its respective domain, its respective server, being processed, and then information being returned to the client or to the browser and the website. So they play, obviously, a very important role in all of this as well. So some key things to look at when it comes to the tags and how they are playing into the overall performance of your website. One, like I mentioned before, synchronous versus asynchronous, or sync versus async. Is the request that's being sent up from a tag, or is it blocking everything else from loading? So when you think about user experience and what a user cares about, right? They're coming to your website in order to be able to either consume content, so read an article, watch a video, look at some pictures. Might be coming to your website to shop, in which case they need to be able to see the products, have the ability to dig deeper into the products, have the ability to add those products to a cart. Or they might be coming to your website just to browse. In any case, they need to see the style of the website, they need to see those images, and they need to see the content. Now, if you have a tag that is loading synchronously, and say it's something that has no effect on the actual page content, so what the user is going to be seeing, it might be like an analytics tag, but it's loading synchronously, and there is some sort of a server issue on the actual platform side. So the latency, the processing time that it's taking on the server side is a long time. Your actual page content can't load in that case. It's blocking everything else from happening. So synchronous tags, definitely something you want to be more keenly aware of. Now, most tags now load asynchronously, so their requests are able to run in the background in parallel at the same time as the actual content of your page being loaded. But some, namely like your A/B testing platforms, are going to still be synchronously loading tags because they affect things with the actual what's displayed on the page, so what the user is able to see. Another thing to keep in mind with tags is that the request size and volume of those requests matters. So the request size and the volume are going to have bandwidth implications. Like I mentioned before, if your users are using something with a mobile device, say, and they're on a 3G network, their bandwidth, or the size of the pipe in which the requests and the responses can be sent through, is going to be smaller. As such, if you have a whole lot of requests, or if you have fewer requests that are very large in nature, a smaller amount is going to be able to get through that pipe or across that connection at one time. So it's going to slow down everything, including, even if everything's asynchronous, it's also going to slow down the loading of the content and loading of everything on your website. Another way that this comes into play is with piggybacking and what some consider daisy chaining, or for the ad tech folks, waterfall of tags, which is when one tag will, well, one of two things. Either one tag will load and then it will inject other tags into the page that will then load and execute and send up requests, retrieve information, the whole nine. Or a request will go up to one platform and then it will start turning around and communicating with other platforms and other tags and other servers in order to be able to piece together all the information, which you see that a lot with advertising. Obviously, tags, a request might go up to whatever it is that's serving the ad on the website, be it a video, but it needs to turn around and get some third-party information about that user. There might be a cookie match or something, so other content that user has consumed, other sites that user visits, and then can marry that information together, send it up to another server, another platform, in order to be able to retrieve the most relevant creative, and then finally turn around and serve that and display that to the user on the website. So in that case, that waterfall effect or that piggybacking is just going to slow down processing time on the server side, which again is going to increase latency. So you're going to have more outstanding requests. Request is going to be sent, nothing returned, so your browser is still going to be waiting for that return primarily. And with the browser limits that I mentioned earlier, there can only be a finite number of outstanding requests at one time. So if that limit is ever reached, that's going to put a pause on any other tags or any other pieces of the website sending up their requests, which again is going to slow down overall load. The nature of tag requests also matters and also plays in to the performance of your website. So all different platforms, there's so many different types of marketing technology, advertising technology tools out there. They all perform different functions. Some things are super, super basic. It might be just a counter, like very basic analytics, for example. Originally, it was just how many page views have I seen on my website. Those are just very simple counter tags. So it's just sending up a hit each time a user loads a web page. Now, other tools, they might inject additional information into the page. I mean, even a relatively lightweight tag now, but in the context of like analytics. So for example, Google Analytics. If you're using their e-commerce functionality and you have that enabled, the standard analytics code is going to execute. It's going to send up obviously what page that user is on. If it is, a checkout page or an order confirmation page, it's going to then return the e-commerce object, which is another piece of JavaScript which actually loads the full e-commerce library, which is going to give some additional context and additional things on the client side that tag can use. And then it will capture all of the transaction information, product information, all that good stuff, and send that up. So multiple requests going on there, several different functions going on there. And it's the same across a lot of different platforms. There might be looking at cookies and the whole shebang. But moral of that story, I digress some, but there are different types of tags, a lot of different functions. It affects the processing that's required. So certain different platforms, certain tags are going to use more CPU, for example, of the machine, or require more requests to be sent and received. Another factor is, again, the latency of vendor servers. Here we'll see a lot of our clients now are starting to have SLAs and have things defined where any platform that we work with has to load or have average latency beneath 300 milliseconds or 500 milliseconds. And that's just really holding them to their standard that, yep, your servers aren't going to die and your servers are, and the functions and everything that you're running server side is going to be efficient enough to be able to return a response within a reasonable amount of time. Because again, if it's not, you have outstanding requests, so the requests might not be able to run, and your browser is just waiting. And because the browser is waiting, the user is then waiting for whatever it is that's being powered by that tag to actually happen. So we went through that. So that's the basics. So we've gone through the definitions, so what it is exactly that we're talking about and the different items that are going to be tossed around, the infrastructure, how each piece of that infrastructure plays in to overall performance. And now we can go into tags, and their impact, and then also some different items that we're going to really want to focus on for optimization. When it comes to tags, one, they're additional requests. It's that simple. Everything that's happening on the website has its root and a request, and tags are more of them. So it's a little bit more of a strain on the browser, on the connection, on the bandwidth, and then you're more reliant on other third-party servers in order to be able to return whatever it is that's being requested. If synchronous content loading can be blocked by tags, again, we went through that a little bit, but it definitely has an effect. What content is being loaded, how quickly is that response happening? How quickly is that content able to be loaded? Now, if asynchronous, it can still have an effect here just because it can bog down the browser, it can bog down the CPU in the case of a poorly performing tag, which is going to then cause the content of your web page in your browser to render that in a more slower fashion. Processing necessary, again, that goes into what we had just mentioned, as well as the layout and display of your web page can be affected depending upon the function of the tag. If it's an advertising tag, for example, and something goes wrong or it's taking too long to load, that's why users, one of the things that I hate, it looks like the content is being loaded and then the browser will refresh in many ways the page in order to be able to load and display a video or something of that nature for advertising purposes. And then at the end of the day, it also takes up bandwidth. More requests, larger requests, more bandwidth being used, more CPU being used, and more for your browser to do. So how do we fix it? What are the things that we want to optimize? What do we really want to look at and focus on as we're trying to optimize this entire process? So the end goal, obviously, is to optimize the user experience. How are we doing that? One, we're trying to get the content in front of the user as quickly as possible. So the pure performance of the website is instant, if possible, in many cases. Number two, we need to be collecting information about what are users consuming, how are they behaving on the website, so that you can then optimize the user experience in that context. Doesn't matter how fast you can get information or content in front of the user if it's not relevant. At the same time, you might have the most relevant content in the world, but if it takes 5-6 seconds for it to load, users probably not going to stick around and wait for it. So it's two pieces there. In order to be able to optimize that user experience, we have to keep tags in mind. Because one, like we've already gone through, they are affecting the site performance and the response time. And two, tags are what's collecting information, behavioral information, user information, all of that about the journey and the users on our site. So if tags are performing poorly and blocking, even if it's just blocking other tags from loading and other information from being collected, we have gaps. We have gaps in our coverage. We have gaps in the data that's being able to be collected. We can't properly optimize our website for our users. So we need to have one goal load times for content. So what it is that the user is able to see, as well as goal load times for all assets. So this is going to help us just have a high level figure that we want to get beneath. But in order to be able to accomplish that, we're going to need to start looking at the different pieces of the overall journey of data, and again, going back to how our website's working. So number one, on the client side, you need to ask yourself, who are my users? What types of devices are they using? If most of your users are using mobile devices, you need to consider that the processing power is going to be less than if most of your users are using MacBook Pros. If the processing power is less, you need to simplify the website. You need to limit the tags and the content, the images, the whole nine there, so that the typical type of device and the typical amount of CPU that a user is using on your website is able to handle it. Number two, what does processing look like? So on the client side, what type of browser are they using? Factor in the max number of requests that different browsers can handle at one time. Start looking at, okay, how many tags do I have on the page? How many requests is each tag sending? And then also in the processing thought, factor in the max number of requests that different browsers can handle. Again, how much code then is being injected to be processed client side? If thinking about the processing power, if there's a lot of code being injected, if there's a lot of efficiency issues with the code that's being injected and it's taking more effort from the client's CPU, from the client's browser, it's going to affect experience. Second thing to then start looking at and questions to start asking is with the connection and the pipes. So what is the typical bandwidth for your profile of users? Based upon the size of the pipe, you're going to need to factor in the size and the volume of the requests that you're making. If you have a lot of users that have limited bandwidth, we can't be loading 50 tags knowing that 20, 25 of those are piggybacking in other tags. It's just too much. Especially, we need to start looking also at the size of those requests. Again, limited bandwidth, lowering the size of that pipe that's going through, the more difficult it is to fit more through it. So we need to keep that in mind. The other piece with the connection and those pipes is, where are your users? If you have global users, you better make sure that the different marketing technology vendors that you're working with can, at the very least, serve their technology regionally, but doing that globally. They need to be able to serve their technology from reasonably close to where your users are trying to access that information. And then finally, looking at the server and vendor side, that's when you're starting to look into latency and then their performance. So how quickly from when a request goes up can you get at least the return being initially started to be returned. So a few other considerations then here with the tags. And one thing is, do not consider anything with tags and tag latency and how it's affecting performance in a pure vacuum. All of these different factors combine together in order to be able to negatively affect the performance of your website. So everything needs to be, you need to have a plan, and you need to start addressing that for each of these. But for individual tags, start thinking about how exactly is that tag being loaded? Is it loading synchronously and blocking the page from rendering, or blocking the page from showing up? Is it loading asynchronously and just competing for resources with other requests? Is the tag manipulating anything in view? Is it noticeable at all to the user when it loads? It could be like an image, a video, an advertisement. How does it load? What is its function? And that's going to really dictate how it is that you need to treat these tags. I mean, if a tag is loading synchronously, you're going to need to have much stricter guidelines and much stricter requirements for that vendor in terms of latency and speed and size than versus something that's loading asynchronously. Next thing is piggybacking. So is the platform or the tag that you're looking at or that you're implementing, is it loading in more tags, or is it communicating with other platforms in order to be able to complete the request? At the end of the day, what piggybacking means is more requests being sent, more wait, more processing, just more time for that particular request to work. Now, again, in a vacuum, this might not really matter from a performance standpoint. If you have a ton of excess bandwidth, if your users have plenty of CPU, but if you're pushing the limit, if you're trying to maximize the amount of stuff that you can be doing on the website for your users, and you're not accounting for tags piggybacking or loading in other platforms, you're not aware of it, can definitely start having an effect on performance. Next thing to keep in mind about an individual tag is its latency. Like I mentioned before, many clients are now starting to think about what is the acceptable threshold for vendors. Again, it could be 300 milliseconds, 500 milliseconds. Really depends and is unique for the website. Start looking at the request characteristics. So what is the request volume? What is the number of requests that are being sent by a number of hits being sent from an individual tag, an individual platform? And then also, what are the size of those? And if a tag is sending up 20 hits at 50 bits versus one tag sending up 10 hits, each of them 500 kilobits or kilobytes, that is much different. The size factored in with the frequency, you're looking at the overall weight then for that platform. You need to start figuring those sorts of things out and seeing how is this larger tag or this tag that's requiring more resources from my users, how is it playing? Is it playing nicely? Is it causing issues? The other final piece here is the processing necessary. How much processing power is necessary for whatever this tag, whatever this platform is doing to actually complete? Some scripts take more to execute than others, more CPU, and you can start looking at things like tag load start time versus end time to get an idea for that. So just to summarize, we went through originally how sites work to get an understanding of, what are the requests, what are the different factors that are playing a role within performance. We looked at the tag's role in that process, how they fit, how they can affect website performance, and then some of the different items to look for and some of the different things to optimize. Now, again, I want to stress one final thing here, and just that there is no magic bullet when it comes to optimizing performance. Obviously, the ecosystem is complicated. There's a lot going on there. There's a lot of factors involved, and tags are one of a handful of those factors. And they must be factored into the equation, absolutely. But if nothing else, the performance impact really underscores the need to understand what's going on the website, what tags are there, how are they functioning, and developing some standards around those different things, developing a very solid tag policy, monitoring against it. There has to be some controls in the implementation process, has to be some controls in the request process in order to be able to keep a handle on the tags on your site and really have a good understanding of how they are affecting the performance and the user experience there. With that, I'll open it up to any questions. Feel free to drop them in. This question is related to GTM. So what GTM tags, the question is, what GTM tags would I recommend to avoid or reduce the number of with respect to JavaScript variables, custom HTML, events, conversion, template tags in order to be able to improve performance? Very good question. Directly related to GTM, it really depends. I always recommend to use the template tags within any tag management system if possible, because at least I like to think that the code in those is going to be optimized as much as possible. I've seen custom HTML tags in all sorts of different tag management systems that can get a little unwieldy. Some people that are implementing tags there won't leverage things that can reduce the weight of tags, such as using those custom variables, using just functionality built into the tag management system. They're still trying to scrape pages, run a lot of different functions in order to capture information, as opposed to leveraging like a data layer and things like that. So I always recommend, one, use those templates if they're there. And then two, for tags specifically, it's a general rule of thumb. Typically, like a custom image pixel is going to be a lighter weight than full JavaScript or full custom HTML. I'm always leery of tags that within GTM require you to enable that document.write, because that means they're going to be injecting additional items into the page, which could be more tags, which is going to take more processing there. So that's another thing to keep an eye out for. And then finally, different tags that are piggybacking or loading in a lot of other platforms. just because you might only think, yeah, I'm implementing this one widget, when in fact you're adding 10, 12 different tags, different platforms via that one widget that are loading in, sending up a whole lot of different requests, and causing issues there. So more so looking at the tags themselves as opposed to one piece of functionality, I guess, within Google Tag Manager specifically. One question, how do you know if a tag is synchronous or asynchronous? They should let you know. I would say 95% of tags nowadays do load asynchronously. Another thing that you can do if you do have a synchronous tag loading on your website, it's going to be the only thing that's loading at that time. So if you're looking at those different network requests, you can get a feel for it that way. But yeah, most of the time, or 90% of tags now, I'd say 90, 95 load asynchronously. It's your A/B testing platforms primarily are the things that are going to be loading synchronously. Maybe some older platforms if you have real old tags or platforms on your website. Any commonly used tags that are heavy on piggybacking? Yeah, there's a number of them. A lot of your advertising tags will be a lot of like sharing widgets, especially social sharing widgets that offer like the free functionality of being able to add like just the share functionality to Facebook, Twitter, Pinterest, whatever it may be on your website. I always like to tell people nothing's really free. So yes, while it's great, you don't have to develop that sharing functionality or do it uniquely for each platform. Things like share this, add this. A lot of times they're piggybacking a whole lot of third-party data aggregation platforms on the back of them. So be leery of those. If you want to see, if you are running any or how big of a factor piggybacking is on your website, the Tag Inspector scans are great for that. You can go on the Tag Inspector website and taginspector.com, and there's a free license available. Sign up for that. You'll be able to run a handful of scans of up to 50 pages, and you can really see there how what tags are piggybacking and what that looks like on your site. But yeah, social sharing widgets are definitely the biggest thing, and then also a lot of the advertising platforms that are out there. Another question, how do I know if a tag is piggybacking? So in order to be able, one, you're going to know if a tag is piggybacking like for that particular tag if you have no way of seeing the script in in the source, if you didn't implement it, or if it's not loading directly through like your tag management system. So piggybacking tags, sometimes it'll be JavaScript that's wrapped up in other JavaScript. So you might implement one snippet, one tag on your actual site, and then that's obviously executing. In order to be able to see what it's executing, you can execute it yourself in the browser, and you can parse through that code to see if there's other JavaScript that you don't recognize, which might be another platform that's piggybacking on in there. Another way is you can start looking in the sources section of your browser's developer tools. It's a little bit difficult to identify, what the root source is of a tag that's being piggybacked just purely using the browser, but you can get down into it there, and you're going to see, based upon the source that's listed, you're going to be able to see if it's loading, from the page source or via GTM or your tag management system there. As far as how do you know if a tag is piggybacking others, that is, you're going to have to kind of reverse engineer it. Once you're able to identify that a tag is loading in via being piggybacked, trace it back to the source, or again, take a look at the Tag Inspector scan reports, and that can help significantly there. It's going to show tags that are being piggybacked, and it's going to show what different tags, what different platforms that they're loading through. Any other questions at all? No? Okay. Okay. Well, thank you all very much. Doesn't look like we have any other questions at this point. If there are any kind of late ones, always feel free to just reach out to me via email. More than happy to respond. I'll also see any that didn't quite make it through when we pull down the like summary of this. We will be sending out the deck as well as the recording of this webinar here probably tomorrow would be my guess. But thanks everyone for joining. Be on the lookout again for next week. We'll be going through how to actually start addressing and seeing some of these different metrics to begin the optimization process within Tag Inspector. But until then, thanks again, and hope you guys have a great weekend and beginning to next week. Thank you all.